Hello there. I'm Rob. I'm that developer dad. This morning we added some new capability to our dice bag. We're able to now pass in an adjustment to the dice roll, and we added some tests, and we see that our tests are working for the single set of parameters that we're passing into the roll object. And that's fine. We know our test works. But one single set of parameters out of possibly hundreds of different combinations is not really a great test. So what we want to do is we want to run some more experiments using these same test methods. And we're going to use the same technique that we did yesterday for the basic unadjusted rolls. And we're going to set up parameters on our tests. And then we're going to just test a couple to make sure everything works. And then we're going to use a class to generate a large set of our test data for each of these methods. So let's dive in. I'm going to change my screen so that you can see what I see. Here we are. And let's start with this one. So dice bag, when result modifier is not 0, it alters the result. And to keep our parameter list from going off the right edge of the screen, I'm actually going to pop that down on the next line. And we need to be able to inject an integer, num rocks, and let's not use shortened words. So number of rocks, we're going to take in what kind of rock, math rock kind, math rock kind. We're going to take in an integer that represents our result, no capital R's, result adjustment, spell it right. And we also want an integer number of runs. Let's get rid of that, number of runs. I spelled adjustment wrong. And let's change the name of this to, we're going to use a little trick here, number of rocks. Very good. And now we see that int number of rocks is the name of one of our parameters, but we also see that when we used it, it changed appropriately. So let's get rid of that. We don't need it anymore. And we've got rock kind down here, math rock kind, and rock kind is what's being referenced. So let's rename this guy to math capital R rock kind. We get the same error, but we can get rid of it. We've got result modifier down here, result adjustment up here. Let's rename this result adjustment. Let's do that. And now it's being accounted for. So we now have parameters on our method. And our fact doesn't like the fact that it's got parameters on it. So we need to turn that fact into a theory. And then it's still not happy because we need to give it a source for those parameters. So we're going to use inline data. And it's got to be a new object array. that is, and let's say 3 math rock kind dot d6. Let's adjust by +1, and let's run 50 for our number of runs. And it still doesn't like it. It must match the number of method parameters. And we've got 1, 2, 3, 4. I may have done it wrong. We don't need the +1 there. Can we just do this? And then do we turn that into an array like so? And it looks like we do. And let's reveal this. Let's drop a breakpoint. Here we go. And let's debug our test that's at the cursor. Looks like our breakpoint didn't take, but here we go. Now it's running. We're not using number of runs yet, but we'll get there. And it didn't run, because of course it didn't. This UI, man. All right, we are now stopped on that breakpoint we added. Number of rocks is 3. Our math rock kind is D6. Our result adjustment is 1, and that's a +1. So let's step over, and let's actually inspect our dice roll object. So here we've got our result is 13. Our result modifier is 1. The roll count is 3. The rolls, it's just an array of integers. We could actually plug in here. We got 3, 6, 3, so there's 12. Unadjusted result is 12. And our result is 13. We're looking pretty good. Let's step over this, and we assert, and our assertion is good, and so we can stop. That's great. Now we want to adjust the number of runs. I wanted to run 50 of them. We only ran 1 because we didn't set that up. So what we need to do is set up a list of dice trays that represents our test runs. We'll say new list of dice tray. Now let's populate our test runs by doing this. For test index equals, oh, stop that. For int test index equals 0. Let's spell that right. Test index is less than our number of runs. And every time we go around the circle, we're going to increment our test index. We're going to take our dice tray and our dice roll up here. Let's pass it there. And then all we're going to do is we're going to add that dice tray that we just got from calling testObject.roll to our list of test runs, like so. We can keep our theory statement. This ain't going to work so well anymore. However, what we've got here is an expression. And we could maybe turn this expression into a function. So what if we said, what if we wanted, and we'll define this as we'll let the compiler figure out what the variable type is. Let's create a variable called evidence function equals. And it'll accept dice roll. And we are going to bool passed equals just grab this whole thing, copy it, paste it in here, return passed. It still doesn't like this. The delegate type could not be inferred. So what does that mean? It means we have to give it a type for this delegate. And the type is a func where we pass in a dice tray and we get back a Boolean. We have to say new like so. And now we have this test that exists as an anonymous function. Well, it's not an anonymous function because we've assigned it to a variable. So if we were just going to run this once, we could evidence function and say, let's just say test index or test runs, and we'll pass the first one. Excuse me. And this will evaluate that. And let's adjust this down so that it only does one run. We'll open up our test lab again. And let's debug it and step through. Do I still have my breakpoint? I do, but it's in a silly place. So let's drop the breakpoint right up here at the start of our test function that we've just altered. And let's debug it. Now this thing I'm doing here, it's a little slick. It's some would say it's more readable, but if I handed this to a brand new junior developer who maybe hasn't learned about functions existing as variables and so on and so forth, that it might weird them out, and I might have to explain that to them. So I'm not super in love with the idea of doing things this way, but it does give us some advantages in certain situations. So we've got our test object. Let's run the experiment. Our test index is currently 0. Our number of runs is 1. We're going to roll 3 d6 plus 1. So we'll just hop over these things. We'll add it to our test runs. We define our evidence function. And here's our theory statement. Now let's step into our evidence function. Dice roll. So our result modifier is 1. So it's going to evaluate this one. And our dice roll result is 6. Our unadjusted result is 5. This is looking good. Passed says true. Our evidence is true. And so our test continues to pass. So the benefit for moving that complicated expression up into a function variable, we're going to see it right now. So instead of evidence only applying to the first one, we can actually say, whoops, scroll in the wrong direction. We've got our list of test runs, right? So we could say test runs dot all. All is a link function. And essentially what it means is you pass all a function or some evaluatable expression, and it runs that expression against every single item in the test runs collection. And if that function or that expression returns true for every member of the test runs collection, then the result of all is true. If even 1 out of 1,000 fails, then all is false. So we're going to pass our evidence function. And let's pop this up from just running 1 test run. Let's do it 50 times. And I'm going to move this breakpoint down here. We'll come back to our test lab and we'll debug it again. Oh, it had to recompile. Debug it a second time. All right, how many things do we have in our test runs? We've got more. Give me more. 49 to 0. That's 50 items in our test run. Let's step over. Go. They're all true. So what we just did in that little blink of an eye is we ran this evidence function against every single one of those rolls, and we determined that we're good. And because we let the compiler turn this function into machine code, it was probably a little bit more efficient than if we had left this function inside this call to all. And it's certainly more readable down here. It also allows us to say our function, it's no longer part of act. So we're going to move that up here. Hey, Chandu, how are you? Just had somebody pop into the chat here over on Twitch, and Chandu is asking me what I am building. So the long story is I run a homebrewed Dungeons and Dragons game. And my players are always asking me about the townspeople that they meet, the shopkeepers and the tavern servers and the leather workers and tailors and blacksmiths and all those people, all kinds of details about these just folks that live in the towns they visit. And I'm not really great at ad libbing. So I got it into my head that I could maybe build a simple, it's not going to be pretty, it's going to be a console app, but a simple character generator for D&D. Now, you said, oh, you thought it's going to be some sort of web service. Well, that's the beauty of the design style that I'm using, because the way I've designed this and the way we're building it is actually as a series of projects using dotNet. Right now, we've just got a console client, and we've got this, which is going to act as the API that the console app is going to call. And then the townsfolk manager, it calls the dice engine and our different resources and so on and so forth. Now, just because for the purposes of this set of streams, I'm just going to throw a console client in front of it, because I'm going to be honest, I suck at web interface development. It takes me way too long to get something ugly. So I'm just going to make a console app. But if I wanted to throw this behind a web API or a web service, it'd be a matter of spinning up an ASP.NET application, referencing my townsfolk manager and dropping a minimal API in front of it to expose all of the functions that the townsfolk manager makes available. If I wanted to throw it behind, say, a Maui interface or a Blazor application, or actually, Maui is a perfect example. Let's say I actually understood iOS and Android development. I could build iOS and Android front end applications and then just pull this stuff in and then deploy it as whatever. Does it make sense now? So that's why I'm following this modular approach. It's not necessarily the importance that I place on what I'm doing here isn't necessarily on the use case. I'm just using the use case to demonstrate how we can design and implement our applications so that they can be repurposed to virtually any kind of delivery scenario, and also how to design those back-end systems in ways that when the project manager comes along and says, hey, great, now we need you to generate rhinoceroses and giraffes, but only on Tuesdays. If we had built this in a very tight, coupled, one step at a time manner, we'd have to throw away a lot of code to turn this from a blacksmith person generator into a giraffe maker. We'd have to throw an awful lot of code away. But because of the way we've designed this, and I actually cover the design aspects in earlier videos in the series, I'll ask my mod 9 of 12 to post the URL to my website, and from there you can find my YouTube account and also indexes on the projects that I'm building, and that'll give you an idea of what's where. And like I just said, okay, 9 of 12 just posted the URL to my website. It's thatdeveloperdad.com. If you click on the projects menu item at the very top of the screen, it's going to take you to a list of articles that I've created about the projects that I've built during these streams. And project 2, Game Master Tools, that's what starts with this .NET application development stuff. And I start from, I have an idea, and then I design what I think would be a good solution to that idea. And then we get into actually developing it over the course of all of the videos I've posted this week. I'm going to get back to this real quick because I want to get these tests rolling. And then I want to get to adding some more tests for another variation on this ability to roll dice. So we've got our evidence function. It's up in here. Our theory statement, it really also belongs up top where we're setting up our experiment. And I think these guys should be here. So our theory statement. And as I've been doing this project and developing my tests first, because when I'm doing something complicated or with a lot of logic and math and stuff like that, try adding a www dot in front of it. 9, please. And you might need to add HTTPS. Like a direct web link like that may not work. So I noticed as I was writing out these tests, I started talking about them in terms of the old scientific method that we learned in high school. Each one of these tests is automating an experiment for us. And you can see here where I say arrange, act, assert. All we're doing, and even the testing framework I'm using seems to lean into that that concept. We have a theory, so we state our theory. The result of the roll is adjusted by the modifier amount. This describes the test for our experiment. That's our evidence function. Here, we're setting up our laboratory. We perform our experiment, recording the evidence into our test runs, and then we're analyzing the evidence and reporting. So I really like using the concept of the scientific method as an explanation for why sometimes we want to write some of these tests. Now, these types of tests aren't always a good idea. And we'll get into that when we start working with the resources for the for the townsfolk generator, because sometimes these types of tests, when the functionality of a component depends on the way certain data exists in some system that we don't have complete control over, sometimes our tests get a little hard to repeat. Like if we rely on certain values of data being available in a database, we probably don't want to think about creating unit tests for those, because we can't guarantee that the necessary data for that experiment is going to exist at any point in time. But for something like this, where all we're doing is mathematics and calling functions that are built into the dotNet framework, we're perfectly fine. All we're doing is calling on random and passing it 1 to number of dice and adding them up. We're just making sure that all works for us the way we've put it together. So we've now got one experiment, and that's pretty good. I could add 3 or 4 or 5 more of those, and that'd be all right. But that's not good enough. Oh, is my website down? Let's find out. I will go there. Open. I just heard Mrs. bellowing from upstairs. It's up. So here, let me grab this URL, copy. I'll paste it. Come on. Jinkies. Streamlabs is being silly. Here we go. Paste. Go. Yes, that's my mod yelling from upstairs that it's up. So yeah, there must just be something funny happening in browsers and stuff like that somewhere. It came up just fine for both of us, so it's not just working on my machine. All right, so we've got that. Our inline. We could copy and paste this a couple of times, but no, that's not good enough. I want to run hundreds or thousands of different combinations of these parameters with a click of a button. Let's do that. So yesterday afternoon, I've already done this for our unmodified methods where we're just rolling different combinations of dice, but now we're accounting for magic weapons and strength and dexterity bonuses and stuff like that. So I want to be able to test that new capability that we added this morning. So we want to, I copied and pasted this in earlier. We can get rid of that. However, we do still need math rock kinds. I am creating a list of test cases, and each test case is just going to be an array of objects that we can pass into our methods. So for each kind of math rock, we want to test where we roll 1, 2, 3, 4, or 5. I'm going to bring this guy down here. So we'll cut them, paste them there. So we want to keep the runs per test reasonable. So we've got our dice count cases. This is basically just creating an array with elements 1, 2, 3, 4, and 5. Our modifier settings is creating another array starting at -5 and counting up 11 times. So that's going to get us -5 through +5, including the 0. Oh, this isn't an IEnumerator. This is using the enumerable class. And what it does is it allows us to do things like, okay, so instead of this is the equivalent of me doing equals new int array 1, 2, 3, 4, 5. So when you've only got 5 elements going into your array, 6 of one, half a dozen of the other, right? But when you want 20 or 30 or 1,000, and they're all basically just constant values, typing that manually is a real drag. So I'm using this enumerable.range concept here. Because, well, what I'm doing here is this enumerable.range is actually casting itself to an array. And I didn't want to type out and initialize those arrays by hand when I could just let the machine do it. So, outer loop. For each math rock kind, math rock in math rock kinds. That gives us this. let's get it indented. Short answer to your question, Chandu, the way I did it is way less typing. It may not be as computationally or memory efficient, but it's way less typing. And for the level of coding that I'm doing, I'm far more interested in typing efficiency than memory efficiency. Time is far more expensive than RAM these days. So we want to add, for each kind of math rock, we want to test where we roll 1, 2, 3, 4, and 5 math rocks. So we're going to nest a loop. For each int number of rocks, in dice count cases, here we go. And I'm going to change dice count cases. I'm going to change that to rock count cases. Because people in the groups that I run in call dice math rocks. Now, for each of those, and I spelled this wrong, and spelling always matters in code, especially if I want other people to understand what I'm doing later. For each int roll adjustment in modifier settings, and I'm going to change that variable name as well to adjustment cases. We are going to, whoops, we've got our test cases up top, right? We're going to say test cases dot add new array that consists of, I've got the array, here we go, number of rocks by, and then math rock, then roll adjustment, and then finally runs per test. And it probably doesn't like that at all. Now, I created test cases. Test cases, there's that problem. Implicitly typed array. I did this up here. I probably typed it wrong. New object array. That's what I was missing. Most of my muscle memory these days, after doing software architecture for a good number of years, down to this level of code where I'm playing with arrays and stuff like that, my muscle memory is not what it used to be. Oh, and I copied and pasted the syntax from where I did it yesterday right there. Silly me. Okay. So I have some notes up here that this runs per test is 1,000 for these. And I say we want to keep the runs per test reasonable because of this triple nested loop, even let's say if we have runs per test equals to 1, we have 8 types of dice, 5 rolls for each dice type, 11 variations of the dice roll adjustment. That gives us 440 discrete combinations of type of dice, number of dice, and adjustment. And then this runs per test means we want to run each of those combinations that many times. So at 1,000, we're up to 440,000 executions of our dice roller every time we execute a test that uses this set of test parameters. And we want our unit tests to be fast. So for now, I'm going to set it to 10. 10 isn't going to be a statistically relevant sample size for us to really gain some trust, but I actually want this thing to finish in a reasonable amount of time rather than take most of the rest of this session. So we've got evidence equals test runs dot all evidence function. Instead of this inline data, we are going to use a different attribute. And I believe it's a class data type of, what did I call my test case creator up here? This dice bag adjust results test data. We'll leave it like that. Class data type of, it passes in the type. Very good. I want to compile my test class or my test project just to make sure I haven't done anything obviously dumb. And it's building away. 4 of 6 projects are up to date for restore. Building the dice engine because our test class obviously uses the dice engine, and it looks like it built okay. Good. Let's open up our lab and pull this over so that I can see. This is now no longer a single fact test, it's a theory test. And look at all these test cases. There are 440 of those little boogers in there. And each of these 4 have 80 test cases because we've only got 80 different permutations. No, these are generated test cases using that dice bag adjust result test data class that we were just messing around in, and all those nested loops and the enumeration range and all of that stuff. That's what built out all of those discrete test cases for me. I'll be doing a pull request from my current defined dice bag contracts branch up in GitHub down to the main branch after this session. No, I'm not using source generators yet. Haven't needed them. Let's run this guy. See how long it takes to run. What did we say? 440,000 discrete test runs. It ran 440, all 440 tests, and it ran each test, or within each test, it ran the roll 10 times. Let's make it a little bit more robust. Let's roll our dice 1,000 times for each one of these 440 different permutations. See how long that takes. About 10 seconds. Behold the power of math. So now we've tested this dice roller with the adjustment factor on it 440,000 times, and it returned true for each and every one of those, I've got a pretty strong sense of confidence that I got it right. The CS files with code in it, nah. When it's time to add a new class, I'll show you. It's actually pretty simple. I'll open the manager's project. Let's add new file. We'll add an interface. Townsfolk manager. Give it a second. There it is. I would add the methods and stuff like that here, but we're not up to our townsfolk manager yet, so I'm going to delete that. I don't want to read ahead in the textbook. And I've discovered the hard way a couple of times, or not discovered, but been reminded very painfully a couple of times over the past couple of weeks. When I deviate from my plan, I get myself in trouble. So let's stick with our plan here. We need to modify the other test method so that it does the same kind of stuff that we did here. And I'm going to do that as quickly as I can. Luckily, our evidence function is a whole lot more simple than the one before. We're going to take these guys up top, cut those, put them up here. Describe the experiment. And my indentation got all messed up somewhere. Probably just a bad copy paste. So dice roll, that's no good. I'm going to have to take this guy, cut it, paste it, bump those two lines in. Our evidence dice roll dot result. This is our evidence function. So let's, while we're down here, var evidence function equals new func that accepts a dice tray and returns a bool. And it is going to be dice roll dot result is greater than or equal to 0. I'm probably missing a closing paren. Nope. I'm missing an angle bracket, and there we go. So here's our evidence function. This guy, that line, is going up here where we're stating what kind of science we're doing. And we're just going to leave that alone because we've got a little bit more modification to do here. First of all, our fact becomes a theory. And that's going to make the method declaration very, very angry because we need to take in those parameters. And we want to take in the exact same parameters as we took in up here. So I'm going to grab them. Thank you. And we're going to pop down here and paste. Boop. Okie dokie, we've got all that stuff. And it still says we got to have some test data, and we've got these little yellow squigglies. So let's get rid of the reds first. We're going to take our data to pass into that from our class data, which is a type of dice bag adjust result test data. And just to remind you where we got this, let's go to our implementation. It's right up here. And it's all this commented in out C# and these nested loops and all of that stuff. Can I use that? Nope. Oh, goodness. No, I didn't want to make my fonts that small. I used to have a smaller font, and I noticed that it was illegible when I was looking at things when I export to YouTube. So number of rocks. Oh, you dope. Ha! I got to rename. Otherwise, it's not going to update the rest of the method. There we go. And that's been updated down here. Good. Let's get rid of that. We want to normalize this. So I'm going to copy it into the paste buffer. Rename the symbol to that. Great. Goodbye. Grab result adjustment. Copy that. This. Rename the symbol. Paste. Make it so. Goodbye. Now we've got our test object. We need to create a basket for our test runs to go into. So we're going to create a list of dice tray, which is the result of this dice roll thing. The name dice roll does it. Shush, whatever. So we see that the test object dot roll returns a dice tray. So we want a list of dice trays. Test runs equals new list of dice tray. Call the constructor. And for int test run equals 0. Test run is less than number of runs. Number of runs goes up by 1 every iteration through the loop. We are in C#, not JavaScript, Mr. VS Code. Our brackets go on their own lines. Cut that. Paste that. So we've created our dice roll. We have to add the dice roll to our test runs. Dot add dice roll. Here we go. And we can no longer calculate our evidence based off of a single dice roll. But what we can do is we could say test runs dot all. For everything in the test run, we want to run the evidence function. We have to spell it right. There we go. We are now a whole awful lot easier to read than we were before, because we have stated our theory. We have described our experiment. We have set up our workspace in the lab. We run our experiment. We collect and evaluate our evidence. And finally, confirm or adjust our hypothesis. Hey, Algrave. You know, I'm writing this because of you, right? Algrave just joined the chat. He's one of the players in my homebrew D&D campaign, and he's one of those jerks that whenever we talk to somebody in a shop or a tradesperson or somebody walks into the tavern, he's like, so what's their name? What do they look like? Are they tall? Are they short? How are they dressed? How are they behaving? Do they have any kids? All your fault, dude. Andrew is a fantastic D&D player, and his character, amongst 3 others, one of whom was my wife's character, won D&D on Wednesday night. So congratulations, guys. We've got our true assertion. We've got our test data all set up. Let's take it for a spin. First, I want to recompile. So we'll build this. Yeah, today, Andrew, yesterday I built the ability to roll 10,000 D20 10,000 times if I wanted to. Today, I gave us the ability to roll 1d10 plus Michael's wisdom, dex, magic. So basically 2d10 plus a million for your hit and damage rolls. We can handle those types of calculations now. I've made my dice bag application monk proof. So now I've got 440 different permutations of rolling each of the different kinds of dice a set number of times, and then adjusting the result of that roll from -5 through +5. And I want to make certain that no matter what happens, the ultimate result is 0 or greater, because there's no such thing as negative damage. That's called healing. What if I put a penalty on the damage, and when you did do negative damage, it actually healed the people you're battling against? I wouldn't be that mean, unless it's a boss fight. Okay, so this is running. Oh, you know what I forgot to do before I started this test run is set the number of runs in each test to like 10. I think I've got it set to 1,000 right now. And I think it's running the whole darn thing. At least I hope it's not. Yeah, it's doing that. And you know what? I want to stop that. What are you doing? Is it on a breakpoint? No. What are you doing? I hope we're not in an infinite loop. Nah, we're not. What did I set the number of runs to? It's at 1,000. So that's 440,000 executions. I need to make this stop. Test results, running. How about stop? Does Control-C work? See, in Visual Studio, I'd just be able to say stop. You know what? Haha, quit. That'll stop it. We'll go to code, reopen Visual Studio Code. That's the first time I have ever had to do the equivalent of Ctrl-Alt-Delete running Visual Studio Code here on my Mac. Let's do this at 10 runs per test. No, you know what? Let's do it at 1 run per test. And instead of doing that, I'm going to do 2. Yeah, we'll still do that. Okay. Save. Let's build. Open the test lab. I think we're going to have like maybe Let's see here. 8 times 2 is 16 times 11. We're still going to have quite a few, but that's okay. We're only going to run each one time. So dice bag tests. The result will never be less than 0. Let's just run that one. Seems to be getting hung. I think I've got a bug in my test. What are you doing? Why does it still say 10,000? Oh, that's not even the same test. Duh. Still trying to run. It's got all these things running. Testing, refresh. Not going to let me stop these again. I broke it. I broke it good. So let's see what's going on here. I hope I don't have to reboot. That'd be stupid. Yeah, it's okay. We're all good there. Here's the stop button. How about that? This one, we stop it. This one, hello. Oh boy. Yeah, I bollocked something up real good. Refresh, stop. Oh, I just stopped the refresh. Output, debug console. No, nothing there. Problems? I got plenty of problems. I don't know what this thing is doing. It's lost its darn mind. Okay, I'm gonna have to stop this again. Yeah, I don't see a way to stop a set of tests that's in the middle of running. Goodness gracious. Testing. So there's the testing panel. That doesn't help me. Okay. We'll just quit VS Code again. And I'll reload it. Open. One last try. Okay, here's testing. Okay, it doesn't actually seem to be running anything. What's all this stuff? Rebuild. What are this? Run project associated with this file was the preview. Okay, yeah, get lost. Debug project associated with this file. It's not what I wanted to do. It's still thinking. Blah, blah, blah. Here we go. We should have only one coming in here. So that's unmodified roll must be no more than, okay. Let's do this. Let's shrink. And I've got a region here, we can shrink that up. And let's come in here, drop a breakpoint right there. Do I need to return? Nope. Sure doesn't want that. Okay, we've got a breakpoint here. This is, I'm going to grab the name of this test and drop that up here in my filter. Paste. Okay, and it doesn't like that. Filter. Oh, stop it. Rename. I'm just going to rename this for a second. This one, Rob. Let's refresh our view. I got to save it. And rebuild. So, yeah, I've been writing software for 24 years, and I still do silly mistakes. Here we go. I've got my breakpoint. I do have my breakpoint, right? Okay. Let's debug this one. And it's thinking. Here we go. It is built. We are paused. Good. Number of rocks, 2. D4. -2. Number of runs, 1. Good. Let's step. Test runs, we only have 1 run. Two. Test run. Oh. Stop. I was never incrementing the index of our test run. I was making the total number of runs we wanted to do go up. All right, let's try it now. Oh, Rob, you silly goose. That worked. Oh, that's going to be a funny story to tell. We can take this back up. So rock count cases, 1, 2. We're going to bring it back up to 5. And we can do 1,000 runs per test. Save it. Rerun that one. We should be back up to, holy God, I don't know how many. Yep, 440 discrete cases, 1,000 iterations per case in 9.7 seconds. We got it fixed. And did I do anything weird and dumb down here that's going to break my actual test harness? No, we did not. Okay, good. All right. So in the interest of moving things along, I may actually do the rolling with advantage and disadvantage stuff off stream, or at least getting the tests prepared for that. And then I'll implement the with advantage and disadvantage on Monday. That feels like a better thing. I got to rename this one, Rob. So this is, where is it? Here we go. Rename. Dice bag tests. Test adjusted rolls. Never negative results. There we go. Save. I'm going to run all of the tests just before I sign off and do the checking into source control and all that good stuff. And let's see how it goes. This is probably going to take, I don't know, maybe a minute. And it's rolling, 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 rolling. 28 seconds. It ran 1,063 different permutations of tests. Some of those tests got run 10,000 times each. Some of them only got run 1,000 times each. I'm really starting to trust my component. And with that, I need to start post-production and go do other stuff and so on. And I'll be posting this up to YouTube very shortly. And I will see you all Monday. I'm going to create the tests for rolling with advantage and disadvantage offline, and then we'll implement that functionality Monday morning first thing. We'll talk through the tests as well. And then finally, we'll either move on to defining the actual townsfolk generator itself, or setting up a way for us to see the results of all of these tests. Maybe some sort of analysis of, if I run 3D6 plus 5 1,000 times, what's the distribution of the results like, and that kind of thing, just so that we can get some idea of how actually random it is or isn't, because computers don't do well with random. So have a great weekend. Be safe. Have fun. If you're outside and it's hot, drink a lot of water, please. Use sunscreen, and take care of yourselves.